Greetings, math fans. All right, so today what we're going to do is talk about something called Newton's method for finding roots. And under finding, it's really finding, but we're really estimating. So we're never going to get an exact value, but we're going to get closer and closer and closer to it. Okay? So let me erase this title here just so I have a little more room. And you might have heard of Newton before, right? Sir Isaac Newton, he's kind of a famous guy. He invented the Fig Newton. Okay, I'm just kidding. He really didn't. So here's a nice picture. And as you guys know what a root is, it's where it crosses the x-axis. So this point right here is our actual root. Okay? And what we're going to do is we're going to estimate it. So we're going to start out with one point right over here, just a random point. Okay? And then we're going to draw a tangent line to that. Okay, it's not the greatest. And what's going to happen is this point right here, math fans, that we just picked, this is our first guess. Okay? And what we're going to do is we'll call this x sub 0. And then we're going to find a tangent line to that value. And what this is going to be, this next value here is going to be our new value. We're going to call this x sub 1. Okay? And so let's develop this, but basically what we're doing here is once we get that, we draw another dotted line. This is like our next guess now. We use that x sub 1, and we draw another tangent line to that. It's not a great tangent line. And that's going to be our next guess, x sub 2. And we draw a dotted line up to that, and then draw another tangent line. So you can see what's happening is as we get closer and closer and closer and closer and closer, eventually we're going to be right on top of that point. Okay, it's going to get never going to get there, but it's a great estimate of what's going on. Okay, so let me delete this again here, and just to draw the picture nicer. And here's our, again, this is our actual root. And we'll pick our point here. We'll call this x sub 0, comma f of x sub 0. Okay, and so let's just bring that point down here. So again, that's x sub 0 right here. Okay, and then we draw our tangent line. So again, this is kind of a rough tangent line here because I'm not good at drawing straight lines. But this value right here, we're going to call this x sub 1. Okay, and if I actually label this point, it's going to be x sub 1, comma 0. Do you guys agree? Because it's right on the x-axis, so it's comma 0. Let's make that a little bit neater here, okay? So what I want to do now with that is I've got 2 points, and I can come up with an equation of that. Do you guys agree the slope of the tangent line is really the derivative? Right? So f prime of x sub 0 is equal to, and so that's the derivative, but we can also use it using our old Yox, right? Y over x. So it's y2 minus y1. So we're going to do f of x sub 0 minus 0, right? We're using these 2 points, so we just created the x sub 0 and x sub 1 over x sub 0 minus x sub 1. All right, so again, that's our slope formula, and that's where we're just kind of saying, you know, our derivative slope of the tangent is equal to the slope of that line, which makes sense. All right, let's actually kind of simplify things a little bit. If I cross multiply and then divide, do you guys agree I get x sub 0 minus x sub 1 is equal to, well, that's minus 0 here, but we can say f of x sub 0 over f prime of x sub 0. Do you guys agree with that? And then what I want to do is move these x sub 0 over, so I'm going to have negative x sub 1 equals negative x sub 0 plus f of x sub 0 over f prime of x sub 0. Okay, cool. And then I'm just going to get rid of that negative, so divide everything by -1, and I get x sub 1 is equal to x sub 0 minus f of x sub 0 over f prime of x sub 0. Now, this is actually a pretty key formula here, math fans. What we're going to do is I'm going to actually make this more generic, because truly if I did this again, okay, if I remember I said let's bring this point up to here, and can I draw another tangent line? Okay, we would get the exact same formula, except instead of x sub 1 you get x sub 2, and then instead of x sub 0 we get x sub 1. So here is our general formula. Okay, general formula. No need to solute. This is just kidding. This is Newton's method, and it's x sub. Well, let's take a look at what we actually wrote here. It's x sub 1, so it's the one more, right? So it's x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. That's it, man. Oh, sweet. That's Newton's method. Okay, so that's how we're going to find, with this value here, we're going to get closer and closer and closer to that root. And that's what this is. This is the root that we're actually going to look for. Okay, so let's do an example. What I want to do is I want to just use, I don't really have a scientific calculator, but I have a regular, my graphing calculator, but we're not going to use any fancy functions here. We're just going to use the division and add, addition, and subtraction. Okay, so let's do a first problem here. Let's keep that up there, and I want to use Newton's method to estimate the positive solution to x squared minus 2 equals 0. Okay, and what we're going to do is we'll get we have an initial value here, so I'll call it x sub 0 is equal to 1. The closer you are to the initial solution, the better off you're going to be as far as guessing or estimating it faster. All right, and so what we're going to do is we're going to let x sub 0 equals 1, and I want you guys to find x sub 1, x sub 2, and x sub 3. Okay, so you guys have that. Well, we'll do the first one here. X sub 1 is equal to the first value, right? Remember, so you just use this x sub n plus 1 is x sub n. So you have n is equal to 0 here, right? So it's x sub 0. Okay, so we'll just kind of write the first one out here, and then we'll actually fill it in. So it's x sub 0 minus f of x sub 0 over f prime of x sub 0. So it looks like what we need here, math fans, is we need to take the derivative first. Okay, so let's do that. It's pretty easy, right? Our function is f of x is equal to x squared minus 2. So f prime of x equals 2x. Okay, so x sub 1 is equal to x sub 0, which is our first term, which was 1, minus f of 1 over f prime of 1. It's pretty easy. So it's 1 minus f of 1, plug a 1 into the equation, and you get 1 squared is 1 minus 2 is negative 1. And plug a 1 into f prime, and you get 2 times 1 is 2. Okay, so you get 1 plus 1/2, which is 3/2. That's our first guess. So let's do our next guess. X sub 2 is, now I'm not going to rewrite this over again. I'm going to use my previous term, because that's truly what this is, right? This is x sub n plus 1 is like our next term, and then x sub n is our previous term. So x sub 2 is equal to the previous term, which is 3/2, which we just calculated here, minus, if I plug in a 3/2 into the equation, right? 3/2 squared is 9/4. 9/4 minus 8/4 is 1/4. So it's minus 1/4 over, and then I plug in 3/2 into 2x, so 3/2 times 2 is 3. And you just basically doing a little bit of work here. It's basically saying 3/2 minus 1/12, which is 17/12. Right, that's like saying 18/12 minus 1/12 is 17/12. Okay, so let's do one more iteration here. X sub 3 is equal to x sub 2, the one previous, of 17/12, minus, and then it's f of 17/12, which is 1 over 144, and 17/12 times 2 is 17 over 6. So, just a little nasty fraction action, but you get 17/2 or 17/12 minus 1 over 408, and that gives you 577 over 408. And if you type that in your calculator, just to show what's going on with these in decimal, this is 1.50. This is 1.4166, and this is 1.4142. Okay, so now what I want to do is I pull up our graphing calculator because I want to show you what how do you solve this one. If I just solve this normally, don't you guys agree it's x squared equals 2? So x equals plus or minus 2, or in this case I want just a positive solution. So really it's the square root of 2. Well, let's see how close this is. Let's check this out. Okay, so here's the calculator, and let's just do the square root of square root of 2. Look at that, 1.4142. Okay, and look what we got. Oops, 1.4142. Oh, look at that. That is so cool. So we actually, in 3 iterations, we were able to estimate that root very quickly. Okay, so that's kind of cool. Actually, I want to use the, and that's just using your scientific calculator. I want to use the functionality of our graphing calculator a little bit to figure some of these things out. So let's try another example. And we're going to do, we're going to let our equation be y equals x cubed minus 3x squared minus 4. Okay, and we want to find the roots of that. So what we need is, as we know already, our equation, right, is going to be the previous term minus f of x sub n over f prime of x sub n. So what we really need is that's our y value, and don't we need the next one, which is going to be our derivative? But do we need to figure out the derivative? No, we're going to let the calculator figure it out. All right, so let's plug some things in here. Bring up our calculator. This is very exciting, math fans. Okay, so let's clear this, and our equation is going to be y is equal to x cubed minus 3x squared minus 4. That's y1. Okay, y2 is going to be the derivative of that, so it's math, and basically it's going to be 8 n deriv. And we're going to do vars, cursor over to y vars, function, and enter. So we have y1 in there, and then our two parameters are going to be, it's going to be comma x, comma x. Okay, so now we have our function in there and our derivative in there. Okay, so let's quit out of here. And now what we're going to do is, the first thing I do is I need to store a initial guess. So I'm just going to pick a number here. I'm going to pick the number 3 by our guess and just see what happens. I want you guys to understand, we're kind of do our guess before, so I'll bring back the calculator. But let's just say it was a quadratic, just for the heck of it. Okay, it doesn't matter which side I start from, right? Because if I pick a value over here, it's going to go here, and it's going to give you this root, though, right? Do you guys agree with that? Or if I pick a value on this side, it's going to get this here, and then it's going to try to get closer and closer and closer to this value. So it all depends on which side you're looking at, because you can get this root or this root. So you kind of have to have a little idea of what you're looking for, and maybe you start on one side and the other side, and work your way over and see what happens to get your root. Okay, but as you just gotta be a little careful, because you could, in this case here, obviously we have two roots. It's a quadratic crossing the x-axis in two places, so you gotta be careful to get both your roots. All right, so let's clear this out. Okay, and bring back our calculator. And we have the equations in there already. You guys agree with that? So let's make an initial guess. And I'm going to make a guess of 3. So I'm going to say 3, and we're going to store that. So STO, and we're going to store that in the value of x. So we've got our initial value. That 3 is our initial value. So we can say 3 is the initial value. All right? And now what we're going to do is we're going to say our new value is going to be that value we just stored. Right? So we're going to call it, it's x minus f of x. And then we're going to do var yvar function y1. And okay, so y1 is our original function, and what's stored in y2? It's the derivative. So y1 divided by yvars function y2. So what this is doing is it's saying our initial guess minus the original function divided by the derivative of the function. And it'll plug those values in, because we put x in our function in the y equals, right? Well, now what we're going to do is this is the best part here, is we're going to store that in x. So it's going to use the old value of x for that first part, and then it's going to store that new value into our new value of x. So watch this. We get 3.44. So let me just write that down. So our first guess, first of all, x sub 0 is equal to 3. X sub 1, that was our first guess, is 3.44444. Okay. Now, as opposed to having to type all that in again, you just hit enter. Oh, look at that, man. That's our next guess. So that's x sub 2. X sub 2 is equal to 3.35916. Okay, and then we're going to hit enter again. That's all you have to do, hit enter. So the next one is x sub 3 is equal to 3.35531. Do x sub 4, enter 3.3553. Okay, you can just see what's going on. It's 30, so we're getting close to where it's not changing, which means we're getting really close to that root. Okay, and even if I do the fifth one, x sub 5, we'll do one more, and you'll notice it's really the same thing as that. Watch this. Yeah, okay, it gets really accurate really, really fast. So that would be 3.35530. So that's my answer to this. The approximation is equal to 3.35530. Okay? So it's your approximate root. That's all you do, is you keep hitting enter and enter and enter. It's really pretty easy. Okay? What I don't want you to do, I know you're going to say, well, Mr. Curves, why don't we just use our graphing calculators to graph it? Because you could have. This is just another way to do it. Okay? And really, truly, if you don't have a graphing calculator, that's the way you do it. But if I ask you to do it using Newton's method, or if the AP exam asks you to graph it using or find the root using Newton's method, make sure you do that. So let's, I want to go down here, and just for the heck of it, I want to graph it just to show you. So we're going to do zoom 6, and it looks like it just has one root, doesn't it? Okay, and in fact, let's do that. Let's second calculate, and we're going to get our 0, 2. And we're going to do left bound. We'll kind of move over a little bit, just a little closer. Okay, so here's our left bound, and here's our right bound. Guess, and oh, look at that, man! Check out our answer we have here, math fans. 3.3530, 3.35530. It's exactly what we got by estimating it. Okay, so you can use Newton's method to figure that out. It's kind of nice. Again, this really kind of showed one root here. If you got multiple roots, just pick something kind of close to that, and you're good to go. But a lot of times you're given an initial guess just to get you started. All right, that is Newton's method of finding or estimating roots. And go ahead and have a Fig Newton and think of Sir Isaac Newton. Adios, math fans. Goodbye.